Alright, so in Chapter 3, we are now talking about polynomials and rational functions. 3.1, we first start looking at our quadratic function, and we have two different forms. There's the standard form and there's the quadratic form. So what we're going to do is we're going to practice some problems from the chapter review. It's found on page 435. I am in section 3.1 for now. So first, let's start off by talking about the different forms of the quadratic. Well, I can have f of x equals a times parentheses x plus, shouldn't be a plus, x minus h whole thing squared plus k. 1 second, let me get to my book. Okay, now, I'm sorry. Excuse me. A determines whether my parabola, because remember it's a parabola, whether it opens up, so it opens up, or if it opens down, right? If A is positive, it opens up, and if A is negative, it opens down. The vertex of my parabola is found at the point h, comma, k. And the one thing we gotta be careful with is when we're determining our vertex, it needs to be in the form where I'm subtracting h and adding k. Okay, now if my parabola opens up, so if f of x opens up, then the vertex is a minimum. And try to picture that with the x squared graph. So here's x squared. I always go back to functions I know. That's not x squared. Here's x squared. Well, it opens up, correct? And what do we notice about the vertex? It is the minimum. Okay, it's the smallest point. It's my minimum. If f of x opens down, then my vertex is a maximum. So if f of x opens downward or down, then the vertex is a maximum. And again, I'm going to use the function I know. So this time, let us do negative x squared. Negative x squared looks like this. It opens down, and here's my vertex, and it is the maximum point. Good, so now that we have some background using the standard form, let us practice some problems. So standard form, let's look at number 1, and it says use the vertex and the intercept to sketch the graph. Now I don't want to sketch the graph because we all have graphing calculators. Instead, I want to find the vertex and I want to find the intercepts. So let's work on that. So number 1, it says f of x equals negative parentheses x plus 1 squared plus 4. Alright, so automatically the first thing you have to do, you have to make sure it's in the right form. I want to subtract h and add k. Here I am adding 1, which means I need to write that. That's negative parentheses x minus a negative 1 whole thing squared plus k. So think of it like this. Inside the parentheses needs to be a subtract sign. On the outside needs to be a plus sign. Once you have the subtract sign and the plus sign, it is in the right form, and we may continue. Alright, so let's find the vertex first. So the vertex is going to be the point h, comma, k. So which point is it? Well, negative 1 has to be my h, because remember I always subtract h. So I'm subtracting h, matter of fact. Subtracting h. So it's negative 1, and I'm adding k, so it's 4. So my vertex is at the point -1, 4. -1, 4. Good. What about my intercepts? So let's first work with our y-intercepts. So y-intercept is where x equals 0. Remember, it's on it's on the y-axis, which means x equals 0. So everywhere I see an x, I'm going to plug in 0. And I have f of 0 is equal to -0 plus 1 squared plus 4. And you see I went back to the original function. I can do that. It's okay. Now that I have the vertex, I can write it back as plus, right? And that comes out to be 3. So the y-intercept is 3. So which means I have a point 0, 3. Now the x-intercept involves more work, right? So for the x-intercept, you set f of x equal to 0. You set f of x equal to 0 and you solve for x. So I have 0 equals negative parentheses x plus 1 squared plus 4. And now I'm going to solve for x. I'm going to subtract 4 on both sides. So -4 equals negative parentheses x plus 1. Whole thing squared. Divide by -1, I get 4 equals x plus 1 squared. Take the square root on both sides. And this is the most important part. When you take the square root, when you literally are writing the square root, there are two answers. There is a positive and there is a negative. If I walk up to you and say, what is the square root of 4? Then it's 2. But if you literally say, I am going to take the square root myself, then it's two answers, the plus and the minus. 2 equals, well, the square and the square root, they cancel each other out, equals x plus 1. Then you got to get x by itself, right? So you have two choices here. You have -2 equals x plus 1, and you also have 2 equals x plus 1. Two equations separately. You solve them and you have x equals 1 as well as -3. So your x-intercepts are 1, 0 and -3, 0. Now, just for fun, what else do we notice about this function? What's its a value? What is the a? Hold on, let me get the right color. Not really the right color, we'll go for it. So a is a negative. It's a -1, right? Which means this parabola opens downward. So if I wanted to pretend like I was graphing it, I'll have 1, 2, 3. I'll have a point at 0, 3. That's my y-intercept. I'll have a point at 1, 0. Let me change my color real quick. 0, 3. A point at 1, 0. At -3, 0. And I know it opens downward, which means it should have a shape like this, right? It should. So let's kind of make it, it's only a sketch, it's not right on. If you want to exact, we can use our graphing calculators. Alright, so it kind of looks like that. Okay, so what's the takeaway here? This is standard form. Hold on a second. This is standard form. The A determines how your parabola opens up or if it opens down. If A is positive, then it opens up. If A is negative, it opens down. Okay? The vertex is at the point h, k. It must be in the form x minus h and plus k. If it's not, like my example, you have to put it in that form. Okay? Good. Now, once you know your parabola opens up, your vertex will automatically be a minimum. If it opens down, your vertex is a maximum. Awesome. So let us work on now number 3. It's in a different form, and let's see how that will go. So 1 second, let me change back to what I need. Okay, so now we're looking at number 3. Number 3. And the first thing we're going to do, like we did before, we're going to talk about another form. This is called the quadratic form. F of x equals ax squared plus bx plus c, where a, b, and c are any real numbers, or any real numbers. And obviously a cannot equal 0. If we did that, it wouldn't be a quadratic anymore, it would be a line. Okay, so let's see what we can do here. Well, a still determines whether or not my parabola opens up or down. So a determines whether it opens up or opens down, right? So opens up, or it can opens down. If a is positive, it still opens up, and if a is negative, it still opens down. That hasn't changed. Alright, now my vertex, that's where the difference lies. The vertex is found at the following point: negative b over 2a, comma, f of negative b over 2a. Okay, so let's not get freaked out about all this going on right here. Let's break it down. So let me get a different color. First of all, this is the point x. X is found at negative b over 2a. This is the point y. If you know x, how do you find y? You just plug in x, right? Remember, y is the same as saying f of x. So the first thing you need to do is find the value of x, and then you just plug it back into the original function. Got it? Good. Hopefully. Awesome. Now, the same thing still holds true. If my parabola opens up, then my vertex is a minimum. That doesn't change. If my parabola opens down, my vertex is still a maximum. That also doesn't change. So let's do number 3 now. And it says f of x equals negative x squared plus 2x plus 3. Okay, first thing first, let us find the vertex. So let's find the vertex. But before I even do that, I always like to label my constants, my a, b, and c. Let's go ahead and label them. So what is a, what is b, and what is c? Well, a is negative 1. B is 2. Make sure you're looking back at the form. A times the x squared term, b times the x term, and c is just a constant hanging out by himself. And who's hanging out by himself? 3. The one thing to be careful with is that these are all plus signs, which means when you're filling in your a, b, and c, make sure these are plus signs. If they're not, the negative has to go with the number. So for example, if this would have said minus 3, then c would have been negative 3. Does that make sense? Hopefully it does. Hopefully you're following along. If not, you can always email me and say, hey, I wasn't understanding anything you were saying. Can you explain it to me again? And I will gladly explain it to you again. Alright, so now let's do the vertex. First of all, I know x, the x coordinate, is going to be equal to negative b over 2a. Negative b over 2a. So, what is net b? It is 2, so that's negative 2 divided by 2 times negative 1, which is going to be negative 2 over negative 2, which means the x point is positive 1. Good. Now, how do you find the y? That's right. You plug it back in to the original function. So that's negative 1 squared plus 2 times 1 plus 3. And we have, what is that? 4? 4. So the vertex is at the point 1, 4. So the vertex is at the point 1, 4. Good. Let's find our intercepts. And let's go ahead and start our y-intercept. So let me start with my y-intercept, which means everywhere I see an x, it will be 0. X is 0, plug it in, so f of 0 is equal to, well, negative 0 squared plus 2 times 0 plus 3. It's just 3. So the y-intercept is the point 0, 3. Now the x-intercept involves some work, right? So the x-intercept is where f of x equals 0. So I have 0 equals negative x squared plus 2x plus 3. Now when you remember back to your factoring days, you have two choices here. Either the quadratic formula, one second while I write all this down, quadratic formula, which is negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. That will give you all of your x's, right? Or you can factor, if possible. Factor, if this is not the day for writing, I tell you, if possible. You may not always be able to factor, but you'll always be able to use the quadratic. So what I'm going to do for this problem, even though I know I can factor it, I'm going to choose to do the quadratic just to show you how the quadratic works. So let me change this over to a red. Alright, so we already labeled up here A, B, and C. You see how important it is to have A, B, and C already labeled? Because we used it here, and we're also going to use it here. So it says negative b, well what is b is 2, so it's negative 2 plus or minus the square root, well b squared, which is 2 squared, minus 4 times negative 1 times 3, divided by 2 times negative 1. Okay, so that's negative 2 plus or minus, well, 2 squared is 4, minus 4 times negative 1 times 3, well, that's plus 12. So 4 plus 12 is 16. The square root of 16 is 4, divided by negative 2. Now, again, you have two answers here. You have negative, I should change colors, hold on. You have negative 2 plus 4 divided by negative 2. And you also have, I'm about to run out of room, negative 2 minus 4 divided by negative 2. Now negative 2 plus 4 is 2 divided by negative 2 is negative 1. So for now I have x equals negative 1. One second. Good. And the other one is negative 2 minus 4 is negative 6 divided by negative 2 is 3. So the x-intercepts are negative 1, 0, and 3, 0. So if I wanted to make the attempt to sketch this graph again by hand, well, here's my xy plane, right? XY plane. The vertex is at the point 1. Let me go back for a second. I just realized something. Hold on. I put my vertex in the wrong spot here. How did I do that? I need to come back and fix this after we're done with this problem, okay? Alright, so let's go back to this. My vertex is at the point 1, 4. So 1, 2, 3, 4. I have my y-intercept at 0, 3. My x-intercept at negative 1, 0. And the other one is at 3, 0. Well, that looks better. Alright, so let's connect. Oops. And it opens down just as it said it would because A is negative. Alright, so let me go backwards. Let's go back to this one and let's see what went wrong. My vertex is at negative 1, 4. And I only plotted my x and y intercepts. I did not plot the vertex. That's the problem. That's kind of why it was slanted too, right? It should have a bowl shape. So let's fix that. So negative 1, 4 is right here. There we go. And then we connect. Awesome. And that looks better. Okay. So The takeaways from the second example are the following. This is the quadratic form. So this is my quadratic form. I'm not going to be able to write it out. There we go. There we go. Quadratic form. And that's ax squared plus bx plus c, where a, b, and c are any real numbers, right? Any number they want to be. If a is positive, it still opens up, and if a is negative, it still opens down. The only difference is the vertex. The x coordinate can be found at negative b divided by 2a. Once you find the x, you plug it back into your function to find the y. Okay? As we did here. I found the x, so x was equal to 1, and then I plugged it right back into the function to find y. Good. Your x-intercept and your y-intercepts, they do not change. The only difference here is now, if I have to solve for x, I have another choice out there, and it's called the quadratic formula. This is the quadratic formula. Make sure you have this in your memory. It's very important because you can always use a quadratic formula. You don't always have to factor. It's very simple to pull out a, b, and c and plug it into your quadratic formula if you're not sure about factoring. All right, let me know if you have any questions.